Okay, good afternoon, everyone. Welcome to this side event hosted by Tiger. I'm Danny Coles from the University of Plymouth and a research fellow on the Tiger project. If we could go to the next slide, please. This side event is really designed to be an opportunity to enhance collaboration between universities and industry. As the title sort of suggests, and we hope that that will be a fruitful thing for the future in taking industry relevant research forward. We go to the next slide, please. So just very, very briefly, just wanted to outline the aim of the event. And it's really just to identify areas, as I've said already, that we can form collaboration between industry and research. As part of this side event, we've gone out to industry and asked for feedback on the areas that they're finding challenging, that they feel like academia could help with. And this session will provide an opportunity to present those findings for everyone in the audience. The idea is to document those findings after the session in a publicly available report or paper. We're not sure exactly what form that will take yet, in order to really drive industry relevant research going forward in order to push the sector along. Just a couple of bits of housekeeping, just quickly. The session is being recorded. And as I said, we really like this to be an interactive session, so do ask questions. For everyone that's online, you can post questions in the chat, and we really encourage you to do that, and we'll be able to read those out as we go through the session. We've got contributions today from Orbital Marine Power, Andritz Hydro Hammerfest. I'm sorry, if we could go to the next slide, please. The Catapult, Minesto, and we also got Cambrian Offshore online to take any questions or add any relevant feedback where necessary. So hoping it will be a fruitful event. The agenda, we'll be talking a bit about resource assessment. If we go to the next slide, please. And aspects of challenging in resource assessment, also loading and turbulence characterization, and also cost of energy related aspects as well. So yeah, hopefully that will be of use. We can go to the next slide, please. Okay, so just to introduce the Tiger project and summarize that, we've got Simon Cheeseman here today. So I'll give you the floor. There you go.
Great, thanks very much, Danny. And John's down here wafting a necessary bit of paper that means you've all got to sign up to show that you've been here. This is an important part of the project because the project's actually, run to the next slide, please. Is actually funded by European funding. And so there's a lot of hurdles that we need to leap over, a lot of things that we need to adhere to. So I'm Simon Cheeseman. I work for the offshore renewable energy Catapult. I run the Catapult's offices over in Cornwall, but we've got a very good, close working relationship with the university that we're keen to grow. We're partners here in Tiger, we're partners here in other local regional projects. But it's Tiger I really want to talk to you about, and that's the Tidal Industry Energizer project. And you know, we're here to talk about collaboration and what motivates collaboration. And when I first went to the planning meeting for the grant call for this, the grant funders were saying, yeah, we're really keen to do something in Tidal. We've probably got 3 million to spend. We're looking at 10 projects. And I said, no, that ain't going to make a shed load of difference to Tidal. You know, this was what, 4 years ago. You know, you've got to think much bigger. The problem with Tidal is, you know, it all happens offshore. There's lots of good stuff and research you could do onshore. But, you know, the crux of the matter is when you go offshore, and that's a real cliff edge because that's when things become very, very, very expensive and also very dangerous. And so, you know, it didn't take a lot of convincing to go back to the grant funders and say, you really need something meaningful here. And then we got carried away with ourselves and we were heading towards 150 million euros budget. And they said, whoa, wait a minute. If you go over 50 million, then it becomes a big project in European speak, which means you have to go back to Brussels and ask special permission. And no one's ever done that before. So we don't want to do it. Okay, so we toned it down a little bit. So you know, we've still got a chunky project at 46 million euros. And that's a bit like a magnet. It's a bit like a light attracting moths. It enables people to go out to private investment to get the match for these sort of projects. It enables people to think, actually, this is something different from business as usual. This will enable us to fulfill, you know, some of the things we wanted to do. And, you know, with researchers involved, with engineers involved, there's a common purpose around the tidal sector. We sort of all want it to be successful. We all sort of know what the generic issues are, and we all recognize that, you know, the only way we're going to get over these and succeed with these challenges is to do it collaboratively. And with public funding, we've got to prove value for money. And one of the things is, you know, we don't repeat things. We do it right first time. We make sure we've got the right spread of technical challenges, of things that we're doing. And that's really important to me. And I think the key thing for Tiger is it got the attention of government as well, both the devolved governments in Wales, but also Westminster, because Westminster were very, Tidal was all a bit toxic, you know, 5 years ago. They didn't want to know, they'd been let down before, and they needed a lot of persuading to think that it was worth paying attention to again. And these sort of numbers do make people look up and pay attention. And then you've got to do the next step and convince them what's it all about, why are you doing it this way, what are the stepping stones to success. And so for us, it was, and that little diagram on the left that you've probably seen 1,000 times now, or hopefully you have, was in our Catapult's 2018 report, which looked at the ways to reduce costs for Tidal and get it somewhere when, once we got to 1 gigawatt deployed, we were confident that the actual levelized cost of energy would be around £90 per megawatt. And you could argue, you know, it's somewhere around £200 per megawatt at the moment. And, you know, offshore wind's going for probably £40 per megawatt in the future. But the key thing for us here in the UK is that nuclear, our backbone energy, is around about £90 per megawatt. I know anyone here from France? Gregory, put your hand up. Yeah, I know your nuclear energy is a lot cheaper. And my argument fell on its face when I was in France making this presentation to the funders that side. But it's critical for us, and the project's critical about proving some of those ways of achieving cost reduction. So, you know, achieving economies of volume, learning by doing, actually putting stuff in the water and going, oh yeah, actually that doesn't work very well, but I know how we can do that better. And then sharing that with other people, that's really critical. And then again, you know, that size of project, the amount of partners, the amount of sites we're doing, you all know that any one Tidal project is fraught with risk and problems. Well, we're doing 6. So, you know, that's why we've got David Phillipson. David, put your hand up. He's our program manager for the Catapult. He's just come into the role. So ask him anything you want. It's his 3rd week in. But, you know, that's why we need a really good team around us to be able to sort of manage this sort of project. And the other key thing is the investment community. You know, I don't know if we've got some Tidal developers in here, haven't we? Are they in here at the moment? Not yet. You can't get insurance for interruption of service because no one will back it. Your insurance premiums are really difficult. Your cost of capital is really high. So Tiger isn't just about the technology. It's also about all the other things that go with it, all the critical things. It's about getting investment, making sure there's actually a route to market for Tidal Stream in the future. Next slide, please. So this map just shows the, this map shows all the Tiger sites. And, you know, it's a UK-French collaborative project, which means it's got to be balanced. So we've got to have more or less a sort of 50-50 on either side. So, you know, equal number of sites in the UK, equal number of sites in France. And then here's a brief list of what some of the key partners are up to. It's all about developing new technology. It's all about putting that technology in the water. It's all about switching on new sites. It's all about reducing consenting time. It's all about improving the resource modeling for the channel region. It's all about proving to those decision makers that they need to take another look at tidal stream energy and that it can be part of our future energy mix. Next slide. So, you know, we're here more detailed examples of some of the collaborative activities that are going on within Tiger. The sort of things that we've got going on at the moment, you know, I've sort of highlighted some of those. You know, faster ways to do consenting, supporting people with information where we've sort of managed to not fast track consenting, but get the data collection right and get the information right first time so that we don't repeat the same mistakes at other sites. Cable routing. We're able to do work where we're sharing cable routes to do that together. An important part of that is sharing the cost. You know, putting in cables is really, really expensive. You know, over £1 million per kilometre sometimes when you're laying that. So to be able to share those costs, share that risk, share that vessel usage is really, really important. And then some of the other deeper technical aspects of tidal energy, but more generic sort of aspects about, you know, getting the devices in water, looking after them. And where we want to drive it is towards sort of standardization, volumes of scale. And we love to think about the future when tidal energy will actually think about volume manufacture. And Kieran Frost from our organization will major on the cost reduction elements towards the end of it. And part of it as well is working with our French colleagues and, you know, understanding the problems they've got. They've got some very challenging sites there, all at different stages, and sort of sharing lessons about understanding those sort of sites. And we're setting up a sort of UK-French supply chain, which we've got to do. You know, we want to encourage the market in France. That encourages the market in the UK. That encourages worldwide export. And that's really why we're here today. There isn't a market today. We can have that argument outside, but there isn't a market today. There's no way for these developers to go at the moment. A lot of these businesses are running in the red and have been running in the red for quite a long time. They want to get into the black. You may ask yourself, well, why do they still get an investment in there? Because people believe in it, yeah? And we've got to reinforce that, and we've got to take that out to the public as well and make sure the public understand it. You know, every time I get in a taxi and the taxi driver says, oh, what do you do? I say, oh, I work in the wave and tidal industry. And they go, well, why haven't we got more than that? Why isn't that out there already? And that, you know, usually I've got to my journey's end before I finish with all the reasons why, you know, we haven't got that in a seafaring nation with a fantastic resource around its coast. Why haven't we got more wave and tidal energy? And then the other important thing that we do, you know, go to the Tiger website, have a look at all the great stuff that's on there. You know, have a look at some of the great papers that are on there. We want more. The most important thing about Tiger is it's big enough that although we've got the partners all set up and the funding cake's been divvied up, there's still an opportunity for businesses, for researchers to get involved with the project. We've still got enough funding where we can work with you in some shape or form to help you, to help us creating that sort of market for tidal. So don't think this is a closed project that you cannot get involved in. Come to any of us in Tiger, particularly come to me, and I'll find a way to get you involved because we've got, you know, we've got a little bit of the 46 million left. So, you know, it's not a closed shop. There are opportunities for others to get involved. Enough? Yeah, great. Okay, hope you enjoy the rest of the evening. And make sure you ask questions as well. Any questions now? Let's put it to the test, come on. Come on, there must be one. Who came up with the name of Tiger? What was that? Yeah, I did. Okay, I'll leave you to the next presentator.
Okay, thanks, Simon. That's a really useful intro and summary into the Tiger project. Happy to say now that we've got Callum Miller from Orbital Marine Power, who's going to present some challenges that they're facing at the moment. So if we could go to the next slide, please. And maybe the next one again. Callum, hopefully you can hear us if you're able just to unmute and you can take it away.
Yep, hello. Can you hear me all right?
Yes, we can, yeah, cheers.
Cool. Yeah, Callum Miller. I'm a principal engineer at Orbital Marine Power. Been with the company about 11 years or so. Background in hydrodynamic modeling and load calculations and kind of marine operations, stuff like that. Quick apology in advance. I've got my daughter here watching Paw Patrol next to me, so if I get interrupted and have to disappear for 30 seconds, that's the reason why. I got three slides. Danny asked me to come up with some ideas for areas of research where I thought academia could make a meaningful contribution and areas for collaboration. So I got three fairly high-level slides to kind of stimulate discussion, and feel free to interrupt me as I go with questions. I'll try and keep an eye on the chat, but yeah, try and make it interactive. So the first one was developing best practice for yield predictions. So this has come to the fore for me a bit recently as we were trying to explain to financiers and debt providers the yield prediction process and the steps in the process and how it compares to what they're used to, like in wind, and what the uncertainties are, where the uncertainties lie, how big those uncertainties are, and all these issues. And it's kind of hard to make the case and explain all that at the moment because there's a real lack of best practice. And these guys will be coming from wind normally, where there's there's a way of doing things which everyone's kind of comfortable with, but we don't have that way of doing things yet. And so we need to kind of develop that as an industry. And I made the table here of the various steps in the process, high-level steps that we have to go to, and I kind of color-coded it on where the areas I was finding it hardest to kind of make the case that that we were making good yield predictions, and where I think there is genuine technical challenges that we need to overcome. The first few in the first part of the process is getting your ADCP out there and analyzing that ADCP data, and I think there is good practice that exists for that stage of the process, at least if what you're doing is averaging the ADCP and doing a harmonic analysis. It gets a bit more complicated if you get into turbulence and whatnot, but for the basic mean current speed, I think there's good best practice there. But the next step of validating the site model you've built, your Mike model or whatever you've used, there's a real lack, a distinct lack of best practice there. And the kind of example I give there is that I had 3 different reports for 3 different models for a single site from 3 different, very legitimate organizations, universities and consultancies. And they all explained how their model was validated and again, fit for purpose, and they all gave quite different results for that site. And I think the kind of common theme between them all was that there was no validation data set used in the setup of the model. So all the data had been used for the calibration of the model, which is reasonably understandable for Tide because you don't have much data. You tend to only have 1 or 2 ADCP drops to build your model on, so you can't really afford to set a lot of that aside for validation. But it's not an approach you would get away with in many other industries when you're building a predictive model of not having a very clearly defined validation process. So I think there's some best practice to be developed there of the whole process of building models and the best way to do it, but in particular how to validate models in a consistent, coherent way. The next step of the process is including weight losses in your model, which can be quite significant. And again, there's lack of best practice here in the sense that there's various different ways you can do that, but there's no clear agreement in the literature that I'm kind of aware of the best way or the kind of best compromise way. That's obviously hampered by the lack of data that's available to validate these models, but there's certainly work that could be done to compare models, at least in the meantime, and working towards developing best practice. So that's a big area. And then finally, the uncertainty quantification. So even if you do have large uncertainties in the various steps of the process, developing a common understanding of what the magnitude of those uncertainties, so we can deal with them within the financing process. Again, I haven't managed to find a lot of literature on that, and there was a very good PhD, one of the ID Core PhDs that had the kind of most up-to-date view on it, I think, but there's lots to build on there, I thought. And then these are the kind of questions that Danny posed to me at the bottom of the slide of, how important an issue is that to you? I'm probably running over time, so maybe just skip over that. I think I got the point across there. So if we can go on to the next slide. The next area of research is on turbulence characterization and it's how it flows through the load modeling process. And I think Hammerfest have some similar slides on this in a bit more detail coming as well. So that's good to see that we're talking about the same thing. So turbulence is a major driver for rotor loads and therefore loads in the entire system. But the current techniques we have for representing it in load calculations are quite simplistic, which leads to you either being conservative or taking too much technical risk. And there's a lot of room for improvement there. So the work that I saw was needed, and I know Hammerfest are going to build on this later, is first of all to characterize turbulence across the different commercial sites in a way that's both comparable and can be used in load calculations. So there is literature available for different pieces of turbulence analysis that have been done in different sites. But the metrics to use and the analysis techniques to use are not always the same. So it's not easy to compare one site to another. And the metrics that are produced are usually not ones that can be directly used in the load calculation process. You can't be kind of stuck into a BEM solver like Tidal Bladed or Fast or something like that. So yeah, the information ends up being you can't really use it as a designer. Furthermore, the BEM codes that we do use, such as Tidal Bladed, are all using kind of turbulent spectra from wind. And there isn't really a kind of standardized approach for how that should be adapted to tide. We've got an ID Core PhD going on at the moment to answer that question, but there's a lot to it. So we need to work towards developing standardized ways of representing turbulence at sites and a way that can be used in the design process. So the way I think about it sometimes is in the same way you can characterize the wave properties of site by looking at HS and TP, and that makes it very easy to compare sites. We need to build up a knowledge of a similar thing for tidal turbulence spectra, where you can use TI and the other metrics to be able to compare sites and then do designs for sites. And the comparing one's kind of a big one at the moment, because there's lots of different commercial sites that are potentially available for develop in the kind of short and medium term. But if there's no way of comparing them for this very important metric, the turbulence, it's hard to do the kind of outline designs and size turbines and do that kind of front end engineering when such an important piece of information is missing from the available data. So the specific challenges that we're facing in these areas, high uncertainty in load predictions and hard to do outline designs for new sites without turbulence characterization available. The impact of this is uncertainty in loads and over conservatism and risk. Excuse me one sec. So yeah, researchers could help by helping to characterize turbulence across different commercial sites in a way that's both comparable and can be used in load calculations. And in terms of data that we could potentially provide to that process, we've got the O2 up and running now in Orkney, and it's being very successful so far, pumping out power and data and information. And we would be interested in working with people to understand that data and analyze that data and take learning from it. The one thing I would say is that the experience I've had in the past is often engaging with academic partners to analyze that data and investing time and effort in setting up the projects, sharing the data and all that sort of stuff. And then the project's kind of fizzling out and not really reaching any conclusions. So we would be interested in setting up collaborations to do that sort of stuff. Low data, wake data, and all that sort of stuff. But yeah, we'd be coming at it a little bit, jaded and wanting to make sure that the project was definitely going to kind of deliver in a reasonable time frame. But yeah, keen to speak to folk who might have proposals for how to use the data. And yeah, next slide, last one. Blockage effects. So most turbines to date have been deployed in reasonably deep water. So usually the turbine is less than, the rotor takes up less than, a good bit less than 50% of the water depth. So for us, the SR2000 was at 30%, 36%, and the O2 was at 44%, or is at 44%. But that's because EMEC's a reasonably deep site. Most commercial sites are actually a bit shallower than that, around about 35 meters, or a lot of them are anyway. And at the same time, we want to put bigger rotors in that shallower water. So we're going to be occupying up to 70% of the water column in the not too distant future, all going to plan. And we know this will change the hydrodynamics over the rotors. We know that it will increase the loads and increase the energy capture. So, and probably the net with a good net benefit in that we will capture more energy in comparison to how much the loads increase. So a net benefit, but we don't currently have effective tools for modeling this and doing the design calculations because the BEM codes don't deal with blockage. And it's not entirely clear what the best way to model this is and do the calculation. So some fairly fundamental kind of hydrodynamics that needs to be worked through here in terms of how to model them. Can we just augment BEM codes? Do we need to use horrendously time-consuming CFD? Or is there other analytical techniques that can be applied? I think there's a fair amount of tank work needed to answer these questions. I know that Richard Wilden, I don't know if he's in the audience, is doing a lot of this stuff at Oxford, but I think there's room for a lot more people to work in this area as well. So again, the impacts are similar to the turbulence one. There's uncertainty in load predictions, difficult to compare one site to another, like compare a shallow site to a deep site when you're not sure how the blades are going to behave in the shallower water. And all these things lead to either you taking too much conservatism or too much risk. And that's me. So I'll take questions or hand back to Danny, whoever.
Thanks very much, Callum. That was a great presentation to kick us off with. Just for people's education, then these sort of questions that Callum's posing here, what we're going to do and the questions that arise from the other presenters, we're going to actually take those and consolidate those and put them back out through Tiger to see where we can address some of these issues. And we'll feed them back into Supergen as well to see if there's something we can do about this. Because I'm always amazed to, when I think about the amount of research that we've conducted over the years, that there's still some of these fairly fundamental challenges that seem to be out there that haven't been addressed yet. So we'll be doing that. I've got a question for you, Callum. I hope you can hear me. Just in terms of, the things that you're learning from your deployments at EMEC and how that would differ from a deployment at, say, a headland site, and do these issues get magnified for you?
Yeah, headland sites are a bit different to channel sites for both the floating structure and for the rotors themselves. The main difference, the main challenge I'm facing moving from EMEC to other sites is probably more the depth. So we've had it easy in the deep water where you don't have to worry about a lot of these kind of blockage effects. Because if you think compared to wind, they're very low blockage because they've got all the atmosphere above them for things to expand into. So it is an area where, and if you think that all the load calculation tools we use come directly from the wind, so it is quite a large difference that we've been able to ignore thus far from working in deep sites. But as we move towards occupying up to the 70% of the water column, it's going to become a big issue. So that's the challenge I see in when moving away from EMEC to the commercial sites, like around PTEC and whatnot.
Okay, brilliant. I'll just invite any questions from our audience. They're all a bit shy. Oh, John, have you got one? That's all right, we've got a mic down here.
It's a question that's come over the text. It's from Zoe Goss, and it was some thanks, Simon, for the introductory talk. You mentioned raising public awareness about Tidal 2. This was really to raise the information. There's a new charity called Our Tide, aiming to do exactly that, while providing development opportunities for young people. So there's some awareness raising there, which is obviously important.
Zoe could get in touch with me, and we'll have a look at linking up with that to see what we can do.
I'll put a reply in the chat on that.
Yeah.
Absolutely. Thanks for mentioning that. Sorry, I didn't mean to jump on your questions, but yeah, if anyone who's listening is also interested in providing quotes, we'll be doing some videos to young people. So if anyone wants to get in touch, that'll be nice as well. Thank you.
Okay, thanks very much. Danny.
Yeah, hi there, Callum. Thanks for that really interesting, thought-provoking talk. I was just wondering, so with the IEC standards and things, I guess it takes quite a while to get things through those standards, and they're what you have to abide by in order to develop projects. So I guess that feels like that's a real challenge as well in sort of getting things through quickly. Is there anything else that could be done in that sense in order to help in speeding that process up? I don't know what your thoughts are on that, and whether you have much flexibility to go outside of those standards when you're doing for example, your blade loading work, for example.
Yeah, we do have a lot of flexibility to go outside the standards, mainly because we have to, because as you say, the standards lag the kind of cutting edge by quite a long time. So so I wouldn't be worried about, I think there's a big step there in developing the best practice and using that. The industry can use that best practice before it's kind of embodied in standards. And I think when you explain to stakeholders that, you know, we haven't abided by the standards, but we've done these things for these good reasons, that's generally accepted, and people get that the standards lag behind. So it's not a showstopper, the fact that lag exists. It's still very worthwhile developing the best practice and using the best practice before the standards actually reflect that. So for example, when I was writing up yield predictions for sites and presenting those to financiers, the standards didn't really feature in the conversation at all, because they had nothing really to say on, you know, compared to the actual cutting edge knowledge that exists.
Okay, thanks very much, Callum. Last chance, audience. Any quick? Oh yes, question up the back there. We'll have to try and get a mic up to you quickly. Thanks.
Hi, Callum. Thank you very much for your talk. Anna Holcomb from Plymouth University here. I'm just interested to know whether you've looked into the increased wave loading on your device. As I understand it, you're thinking about deploying it at the Alderney site as part of the Tidal project. So I was just wondering if that's something you've looked into yet.
Yeah, the wave loading is part of the process that we're kind of much more on top of and much more comfortable with compared to the turbulence, because it's easier to measure and model and get good information on sites. So, and it's something that's been, because it's such a dominant feature of our device, it's been one of our primary focuses over our whole development over the last 15 years. So yes, we're kind of on top of and comfortable with the wave loading, certainly in comparison to things like turbulence, which is this feels like there's more uncertainty in.
Okay, brilliant. Thanks very much, Callum. We need to move on to the next presentation. So Callum, thanks very much indeed for your time. It sounds like you managed to keep your little one under control. Just
about.
Yeah. Okay, we're going to move on now to the next presentation, which is from Catriona Phillips from Andritz Hydro. The stage is yours. The virtual stage is yours. Okay, hi, hope you can hear me. Yes, we can, yeah. Good. If you just go to the next slide, please. So I am a loads engineer for Andritz Hydro. I've been with the company for about 10 years, so have quite a lot of understanding of the background to do with, as I say, flow characterization here. So a lot of the topics Callum
just discussed are also applicable to us, but I'm going to go into a little more detail on the blade loads particularly, and the inputs that are fed into our model for generating all our turbine loads. So next slide, please. So our current process for generating loads and getting the environmental inputs to our model is kind of described by this basic diagram here. So we've generally got ADCP measurements from sites, and I'm sure most of you are aware you can get measurements throughout the water depth in various like bins throughout the depth. In order to feed this information into our blade model, this ADCP data is processed to come up with the sort of flow characteristics that vary with flow speed. So for instance, the turbulence intensity and then the vertical shear, which you should get all this information throughout the water depth, but into our model, basically the data in terms of the turbulence intensity is taken just at the turbine hub height. The vertical shear is obviously a parameter throughout the full depth. And so this information is then input to Tidal bladed. And the first stage is to create what we call, well, wind files, because it obviously was based originally on wind turbines, but they're still wind files. So these are created and they consider the turbulence and length scales of the flow and the turbulence intensity. And again, this information is just taken at the turbine hub height. And then for the actual simulations, again, the turbulence intensity and the vertical shear. So a lot of the information we feel from the ADCPs is kind of ignored almost and simplified greatly. Next slide, please. So within bladed, this little screenshot here is just how we then generate the wind file, which is basically the turbulence field that is fed into our simulations. So we take the turbulence intensity and length scales and put them in, and then also sort of specify a grid size basically, and a frequency along the time period. And as Callum pointed out before, the models that are then used to recreate the turbulence field are based on wind spectrums and wind models, which obviously are probably not ideal. And Callum noted that it was a topic for consideration. So then these 3D sort of turbulence files that we've then recreated from our ADCP data is then sort of applied to the simulations, and within simulations themselves, turbulence intensity is specified depending on the flow speed of the simulation, and on top of that, a vertical shear profile is included within the bladed software. And generally we run sort of 10-minute simulations where like the hub height flow speed is sort of a constant mean. So we have to do a number of different simulations at different mean hub height flow speeds with different turbulence characteristics and different vertical shears. Within Tidal bladed itself, the sort of inputs that you can apply are, I mean, there is a lot of information in the model, but some of the inputs are fairly limited. So for instance, I've noted a couple here, which from previous analysis of measured data from our turbines and instrumentation on the turbines, we sometimes see, as well as a vertical shear profile, we sometimes see a sort of horizontal shear, or perhaps you could describe it as a twist through the flow. And there's no way of easily applying a twist like this in one of the bladed simulations. There's also no real way of So for instance, for each simulation, you specify, well, longitudinal, lateral, and vertical turbulence intensities. And I've said that these are based on our hub height measurements, and there's no way of sort of varying this turbulence intensity throughout the depth. I think Bladed probably does some calculation based on the shear, but also from previous analysis of ADCP data, we've seen that actually the turbulence intensity itself can vary through the depth. So sort of all these parameters, when you're wanting to ensure that your design is not too conservative, in order to reduce costs and make sure your turbine design is as optimal as it can be, then some of these parameters could possibly play into that. And if we could include them, then it may benefit design and reduce costs. So there are things to think about. So next slide, please. So yeah, just sort of summarizing really for this particular area in terms of like turbulence modeling within our simulations, our thought is, because the fact that the models just now are based on wind and we don't have anything that is directly applicable to tidal flows in terms of extrapolating the turbulence intensities to the full flow field, we're kind of thinking that actually if you could take, for instance, the ADCP data directly and somehow generate a turbulence, this 3D turbulence field that can then be fed straight into the simulations without having to first sort of compress the data and then expand it again within the bladed environment, we think that would be beneficial. Also, you could then include whichever turbulence variation through the depth that is there at the site, and vertical shear would already be included in the data and wouldn't have to be applied separately. And then also it would give the ability to include other parameters such as this horizontal shear if we think it's there, or if we think it's necessary to include, if we think it's going to make a difference to the loading of the turbine. With the ADCP data itself, I don't know how many of you are aware, I guess. There's kind of always questions about how suitable ADCPs are for providing turbulence data, basically for our safe case of feeding into our turbine simulations. But consider it, let's take them as a usable source, then we do get the vertical variation through time. And I think for just now, I had a quick look earlier, and our turbulence field that we use just now, the sort of grid spacing is, well, approximately a meter. It's slightly less than that. So I think with the sort of general bin sizes that are taken through the depth, I would think it should be reasonable to get the sort of turbulence variation through the depth that could just be fed straight into our WIN files. But the question is, would there be a way of obtaining a sort of lateral variation with time? I'm not sure how easy that would be, or even if it's possible. And if not, then sort of another way of somehow extrapolating the sort of vertical data laterally would be required in order to get this sort of 3D turbulence field that is required for our simulations. And then just as a sort of point for consideration to finish on is our ADCP measurements actually the best way of obtaining the environmental inputs that we require for the simulations? Would there be any other instrumentation, I don't know, or perhaps detailed CFD models, whether they 3D, would they be suitable in order to get this sort of 3D section of turbulence, I suppose you could describe it as, that we could then just feed straight into our turbine simulations without sort of messing about too much, I'll say, with the parameters and sort of recreating turbulence fields from data where we would probably already have the turbulence fields initially before compressing it all. So it's just a few sort of more detailed points that to consider in terms of the flow characterization for modeling the turbines, and in order to try and reduce any conservativeness and sort of reduce costs and improve the process basically, and make things easier to run and make my job slightly easier. But that's kind of all for now. Thank you.
Okay, thanks very much indeed, Catriona. We're definitely here to try and make your job easier. Plenty of food for thought, not only in your presentation slides, but the narrative that you put on top of that. So I hope we're capturing some of that as we go along. I'm getting nods, so we are. I just wanted to go back to one of the points you raised about tidal bladed, and I'm old enough to remember when that was first introduced into the market. And there was a bit of head scratching about it, sort of the utility of it and maybe some of the shortcomings. I don't know whether you feel, I don't know whether you still get any support for that, because originally you used to be able to buy it with a support package, or do you think that bladed has perhaps outlived its use now and perhaps there's a need for something else?
Yeah, we no longer get support for it, and I don't think I went to a bladed conference well before COVID, so a couple of years ago, and even then I think they said that basically they'd stopped any further development of the tidal bladed. So yeah, I'm not sure, I mean, how keen they are to, I'm sure they'll still sell you it, but they're certainly not putting any resource to developing it any further, I don't think. From our point of view, it's kind of the only piece of software that we've ever really used for this process. So to change it now would be quite difficult, given that we're a very small team right now as well. So, I mean, it may be something to look at, and certainly if other people have experience using other software or methods for doing the same sort of thing, then obviously it'd be interesting to sort of hear their viewpoints. But certainly from our point of view, it would be very difficult to, or time consuming to start going down a different route. So we kind of have to make do with what we've got just now, but certainly there are some questions over its usability and suitability, really, I suppose.
Okay, yeah, thanks. Anyone in the audience use bladed? Yeah? Do you still use it? Yeah? Do you recognise some of the shortcomings that were identified? Should we just give you the mic so everyone can hear? I'll start again. Do you use bladed?
Hi there, this is Steve Alsop from CIMEC Atlantis Energy. Yeah, so I've been with CIMEC for 2 years as a loads and modelling engineer and completely understand all the points raised in that presentation. And we're in a similar position actually. You go so far down the line and you're kind of restricted by options and time and effort in changing to a different product. I am aware that there are other softwares out there. I think FAST is one of the key ones that is used a lot in academia because of it's free and open source. But as Catriona said, I mean, it's a lot of energy and effort to change to something like that now.
Do you think there's something about, is there a bladed user group where people can share the frustrations but also share some of the learnings, or is it more than that?
I think conferences like this are optimal places to really share your frustrations. But no, not to my knowledge. There's no like proper groups to really discuss what ways to make it better. I think, as Catriona said, I think it's just the software which is now become a little bit restricted in their development.
Yeah. So just following on that point, and there was a question online from Simon Waldron, who asked about how could these sort of issues and some from the previous presentation get taken forward and addressed. And I think what I said before was we're going to do that. We'd take those issues, consolidate them, and put them back out there and invite people to say, yeah, I've got an idea around that, or I'd like to be involved in a further activity to talk about some of these. And I mean, we can certainly fund those sort of discussions and maybe workshops through Tiger. We may be able to do a little bit more around developing. I won't go as far as saying we're going to replace bladed or anything like that, but certainly do something to help developers like yourself and Catriona. That's the intention. Other questions from the audience? John?
Yeah, I'm just trying to relay the chat. There's a comment here from Matthew Topper that bladed is in fact no longer for sale. So I don't know what developers are doing going forwards if they can't buy it. And Ralph from Chatel echoes the discussion around the bladed topics mentioned by colleagues. So the inputs and use of bladed, obviously, things that are common in the developers.
Is that Ralph Starman from Shuttle?
Yeah.
Yes.
Ask him why he's not here today.
Ralph, can you unmute yourself and explain?
Hi, Simon.
Hi, Ralph.
And it's the first UTIC conference I'm missing since I think more than a decade.
Okay, we'll send you one of the T-shirts in the post.
Thanks a lot. No, I need to take care of the kids this week. The wife is out, so unfortunately, first time in 10 years as well. But yeah.
Okay, thanks very much. Sorry to put you on the spot. Good to hear from you. Okay, we're going to move on. We need to move on to the next presentation, and that's Hannah from Monesto. Hannah, are you with us? Hi, Hannah.
Hello.
Ah, hi there, Hannah. You had us going for a minute there.
Yeah.
Okay, great to hear from you. The virtual stage is yours.
Okay, thank you very much. If we can move on to my slides, please. Yeah. Is my video showing? Sorry, I've tried to turn it on there. Let's see.
Slides, Hannah. But if there's an embedded video, that's not running.
No, I mean just my video of me, but you don't really need to see me. But I have tried to turn it on.
We can hear your voice. That's the main thing.
Okay. Conscious of the time. So it's Hannah Torrance-Spence, work at Monesto. I work in the site development team and work in resource assessment. I've been at Monesto about 3 years. David Collier's name is also listed on my title slide. David has helped me put together some of the questions, and David is the COO at Monesto. So one of the research themes that we feel would merit further collaborative research is quite high level, generally on furthering understanding of the real extractable tidal stream, and also for us ocean current energy resource on a global scale. So we'll furthering understanding of the total global extractable resource will require studies on global, regional and site-specific level. But my first slide here is starting off with a key region of interest for Monesto, and that's the Irish Sea. So we would like to really better understand how much tidal stream energy we can extract from the Irish Sea without significantly affecting the environment. And we'd like to understand more what are the limiting environmental factors to this energy extraction, by how much can we reduce the speeds and head losses and in the Irish Sea, and what are the limiting environmental processes, sediment transport or habitat changes, or is it the economics of the energy extraction that are limiting? And we'd also like to understand more, where are the most efficient locations for energy extraction throughout the Irish Sea. I've highlighted a image from an interesting study by Haverson et al. From I think 2017 on the cumulative impact assessment of tidal stream energy extraction in the Irish Sea. It's just an interesting study looking at the interaction between sites and the effect on flow speed reductions and the zones of impact around sites in the Irish Sea. But this study considers relatively small arrays, relatively small levels of energy extraction. So we're interested, looking beyond that, those first sites, to much broader extraction of the energy in the Irish Sea, and also utilising the lower speed, lower energy areas of the Irish Sea that Monesto are also interested in. Next slide, please. So generally then, just on the global extractable tidal current resource, just posed a few questions that have come to mind when thinking about this topic. So first off, where are all the tidal stream energy sites around the world, including the low energy sites? Monesto are also interested in. We know about a lot of sites, a lot of exciting sites around the world, but we believe there's more out there that we don't yet know about. Can global tidal models be made at high enough resolution to identify all the tidal hotspots? And what is the real global available tidal energy on a global scale? There's a lot of studies that look at available tidal energy. They're not necessarily comparable. They're done on a site basis or a regional basis, and the assessment methods aren't comparable between the studies. They've used different screening criteria. Interestingly for us, some of the studies exclude deeper sites that we are also interested in. And beyond that, what is the real extractable energy around the world when we look at the effects of energy extraction? And just some other questions I don't know the answer to, but can satellite data be used to improve understanding of the global tidal energy resource? So beyond the common usage of altimetry data assimilation into global models, can satellite data be used more directly for measurements of currents and identifying sites? Do existing global models, can they capture accurately the interactions between ocean currents and tidal currents? And what are the impacts of that on identifying sites and on assessing the available energy? And I'm aware of an EPSRC funded project called Metric, I think led by Bangor University, that looks at this topic and asks some very interesting questions around the global resource. So we're very eager to know when the results of that study will be available to follow that study further. So next slide, please. Yeah, and then at Monesto, we're interested in exploiting ocean currents as well as tidal currents. So this is very similar questions to the previous two slides, but do the existing global circulation models identify all the ocean current hotspots for energy extraction? Do the models reliably capture the available resource and the variability of that resource? And exact same questions as from the first slide then, how much ocean current energy can we extract without significantly affecting the environment? And what are the limiting environmental factors in this case? So how would energy extraction from ocean currents affect global circulation processes and the biochemical properties of the currents, and what other knock-on effects do we need to be aware of and concerned about? We don't want to cool down Europe, for example, by extracting too much from the Gulf Stream. There is, well, we know there are a couple of studies looking at energy extraction from ocean currents. There's a very interesting one we've read from Renewable University, and they look at inserting arrays into quite a few microsites in the western boundary currents, and they see some interesting effects from energy extraction of shifting currents offshore, of the wake effects, the reduction of flow speeds from one array affecting an array 100 kilometers downstream. So this warrants a lot further investigation. And next slide, please. I think that's my final slide. Is just thank you, and to get in touch if you have any feedback on these topics. In terms of opportunities for collaboration, we're interested in developing project proposals. We as developers can share our site screening criteria and turbine siting constraints. We can share site data, and we can we can even work together on the analysis and interpretation of results from these sorts of studies. Yeah, we're very interested to hear from you if you're interested in the topic. Thank you very much.
Great, thanks very much, Hannah. Hannah, I think with your slides and your discussions about global tidal currents, were you giving us an insight to Monesto's plans for global domination in the tidal market there?
I have to wait and see.
A couple of points from me on your presentation. The first part talked about the Irish Sea. There was some work that looked at, and it was commissioned by the Energy Technologies Institute, probably back in 2015, that worked with HR Wallingford, that developed a model of the UK continental shelf, and sort of turned on all those tidal sites that we were aware of, or the sort of the premium sites, to see what the overall effects were. And I just wondered whether were you aware of that work, and B, would that be useful for you to know more about?
Yes, absolutely. Is that the Smart Tide project you're
That's it, yeah.
referring to? Yeah, I'm aware of it. I'm not unaware of where to find the outputs from that study, if they're still available. And yeah, very interested in learning more about that study.
Okay, we'll try and come back to you on that then.
Okay.
And then you asked about Project Metric from Bangor. Have we got anyone from Bangor University here today? No? Anyone know about Metric? No? So is Brad Mackay online? So Brad is one of the Catapult research engineers. He's got close alignment with Bangor. So Brad, if you can go away and find something out about Metric, and maybe get in touch with Hannah, and we'll put it into the consolidated document.
Yes, I'm online, Simon. Thank you. I'll follow that up with Bangor University and Hannah.
Okay, that'd be brilliant. Thank you very much, Bradley.
Good. No worries. Nice to meet you.
Thank you.
Thanks, Brad. Audience, Any questions there on either global domination or looking at other ways of looking at tidal resource around the sort of UK or around the world? I think the satellite question is an interesting one. I get lots of satellite companies approaching us and saying, you know, how much more they can do. But I suppose I was slightly surprised that you didn't sort of suggest that artificial intelligence can do a lot now to sort of link up some of these, you know, maybe sort of distinct models that we've got and do more to join those up. Maybe that's something to think about. Any other questions? Kieran?
Yeah, hi Hannah. So this is Kieran Frost from the Catapult. So yeah, thanks. It was an interesting presentation, and it's more of a comment than anything, but it'd be great to share your site screening methodology because we're doing quite a lot of this work in Tiger in terms of, you know, the sites and analyzing the capacities. And I'm giving there's a couple of slides on this later on in this presentation. Yeah, so more of a comment. It'd be great. I'll get in touch, and it'd be great if you could share some learnings and we can maybe collaborate on some things in Tiger.
Yeah, that sounds good, Kieran.
Yeah, thanks. Yeah. Good
Interested to see your slides coming up.
Cheers.
Thanks.
Okay, good. Audience, other questions? Come on. There must be one there. You got one online? Yeah, great. Thanks, John.
So this isn't a question directly for Monesto, but it's kind of an interesting point that is echoed by a discussion I had with someone on Alderney a little while ago. So Bill Abel from Alderney asked the question. He says, Alderney's mentioned, but currently none of our tidal resources are being utilized, and more than happy to discuss any interest. And it's just the interesting point, really, that we have these devices. There is a remarkable resource there, but the islanders on Alderney report that they feel that their resource is not really available to them, and they have all this potential, but they're not getting any power out of it. So you know, there is a site there where there is some enthusiasm.
Sorry, I didn't catch the name from.
It's a chap called Bill Abel, but I don't know what his background is.
Yeah. Hi, Bill. It's Simon Cheeseman. So I'm absolutely positive that we've been contacted by Alderney as part of the Tiger project. And although Alderney sits outside the jurisdiction zone for the grant funding we've got, that doesn't prevent us from working with you. We did have a meeting set up to start to look at, I think, energy systems, but that was curtailed at the request of the island because of a COVID situation. So it's on our agenda. And I know, Danny, you've been looking at some issues specific to Alderney. Alderney's a remarkable place in its own right, but also a great place for us to sort of understand how we can sort of, you know, use tidal stream in the future for sort of island applications. So
Bill is online and unmuted and may be able to say something.
Yeah, hello, Simon. Yes, I appreciate that we have engaged through TIO previously. Yep. But again, I take the opportunity to advertise when we can. And certainly it's a shame we're outside of your project box, but we try to creep back in whenever we can. So if you've got a spare door we can sneak in, more than happy to look and see how we can participate.
Yeah, I think there's a door that's open, and I think, you know, when you're ready, we'll pick up that conversation again. I mean, there's certainly enough things that we can do to support you.
No, that's great. We obviously had a couple of hiccups like the rest of the world on the COVID situation and put us a little bit behind. So we'll be chasing up again shortly.
Yeah, no, that's great.
Thank you. Thanks for bringing that up.
Thanks, Bill. Any other questions on that?
No, that's it for now, for that one.
Okay, any other questions from the audience? If not, we'll go on to our final presentation, which is...
Yeah, while that's getting ready, there was a comment from Sylvain Galou. He says we're working on turbulence and flow characteristics in the Alderney race, and there'll be papers on that tomorrow morning in the in that track.
Okay, brilliant. Okay, good. Thank you very much. Our final presentation for tonight is from our own Kieran Frost, and Kieran's going to talk about some of the areas around the work he's doing on sort of cost of energy reduction for tidal stream. Kieran, the real floor is yours.
Very good. Great, well, thanks, Simon. So yeah, hi everyone. I hope you're all having a good conference so far. So my background is I started at the Catapult about 6 months ago, and I'm a techno-economic analyst working primarily on the Tiger project. And one of the things we're looking at is for the 5 Tiger sites, we're looking at how much tidal capacity could potentially be deployed there under different scenarios. So yeah, if you go on to the next slide, please. So this is just a very, very quick presentation just to outline some work that we've done in the Ramsey Sound. So the Ramsey Sound, for people unaware, is a small channel between Ramsey Island and the mainland in Pembrokeshire in southwest Wales. And it's really quite a renowned tidal site. So TEL, Tidal Energy Limited, deployed a device there. And currently Cambrian Offshore, who are a partner on the Tiger program, now have that lease area and are looking at developing it. So what we've done as part of Tiger is we're doing a constraints analysis to try and analyze what areas in the Sound and the surrounding area could be suitable for tidal stream energy. So that's just a map of it, just for some context, showing the previous projects that have been identified and examined to some degree. So what we did for our analysis is we looked at 17 constraints, including the tidal resource itself, including things like bathymetry, vessel density, fishing, environmental constraints, oil and gas, and renewable energy lease areas. So quite a lot of different layers, which they're all freely available layers. So if anyone's interested in doing some analysis of their own, then get in touch. So yeah, next slide, please. So these 4 maps just illustrate some of the softer constraints that really we didn't consider as barriers for tidal stream deployment. So in the case of vessel density, we got this layer from the eModNet data portal, which is, yeah, it's a great resource. I'd recommend everyone checking it out, particularly if you like your GIS data like I do. So it shows really that you can see within the Sound, within that dashed area, which is the analysis area we're looking at, that there's very low vessel density. Equally for fishing, we got a few different data sets, and again, that dark blue illustrates that, yeah, very low fishing activity. So both of those constraints really are not problems for tidal stream deployment, in our opinion. Although there is a degree of subjectivity to all of this, and I can talk about that more if people want. In terms of seabed sediment, so the majority of the domain is this kind of mixed coarse sediment, which again, it's really hard to make a judgment on. So this whole analysis is very high level. So actually, generally in tidal, you'll have either a gravity base or a monopile, which some developers are looking at more. So really, based on the data we had, it's quite low resolution, and we couldn't really make a judgment as to, we didn't want to rule out any area unfairly, let's say. And the same, kind of a similar thing for the environmental protection. So the whole area is actually in this SAC. So you might think, well, okay, we can't put anything there. But actually, evidence suggests that's not true, because TEL deployed a device there, and they were also looking at the St. David's Head area. So again, we figured that because previous projects have been deployed here and have got marine licenses, that would not be a barrier to deployment. So these are just 4 examples of the things we looked at that we determined were not problems. So if you go on to the next slide. So these are some of the constraints that we did consider more clearly. So on the top right, we've got the maximum spring tidal flow. So this was provided by Danny at the University of Plymouth. So yeah, thanks Danny, that was really great, the data you provided there. So we applied a cutoff to say that low flow areas would not be viable economically. Similar for bathymetry, so we got these data sets mainly from the UK Hydrographic Office, and again we found that really it's very deep in the actual Sound, but kind of surrounding it there are some shallow waters that would not be suitable for the larger rotor economically viable devices, so they were ruled out as well. And then within GIS we derived some distance layers, so the whole area we were examining was within 6 kilometers of the shore, so we thought on the scheme of things that's a very low distance and would not really be a barrier to deployment. And equally, most of the coastline is actually within 5 kilometers of the 33 kV connection at St. David's. So again, that was not a problem. So if you click next, there's a little animation thing here. So what we did then is we looked at the map. The blue constraints are bathymetry, the red constraints are flow speed, and there's a few other things laid on there as well. So shipwrecks, local harbors. We also derived the seabed slope, which can inform the type of foundation you use. So from that, you can see it's quite complicated, all the different colors, but the gray is essentially good areas that are unconstrained and that we could potentially put tidal devices there. So you see that there's the two traditional areas, the Ramsey Sound and St. David's Head, which TEL Limited looked at previously. And then we also identified these other two areas out to the west that we thought there was quite a lot of gray. And as I said, it's fairly subjective, but the water depth was quite deep, the flow speeds were decent, and there weren't many obstacles in terms of shipwrecks and things. So if you just click next again on the slide, then what we've just done a very high level, okay, what area of the seabed is unconstrained, and therefore how many megawatts of capacity could we deploy there? So we looked at a few different densities, so 10 megawatts per kilometer squared up to 50, which is based on feedback that we got from our project partners as to the device spacing. So this is a fairly high level analysis. We're not considering micrositing of turbines, etc. But you can see roughly that in these areas, in the most optimistic case, there could be kind of, up to kind of 400 megawatts at some of these sites, which I was personally quite surprised about. I thought it was going to be nowhere near that high. So it's a fairly high level analysis. We haven't included things like blockage effects, wake effects, extreme wave heights, etc. So this is kind of the next stage, really. So the next stage is we're going to look at a techno-economic levelized cost of energy analysis to then say, okay, within these 4 areas, is it economically viable? So this is really the kind of technical feasibility study that we've done at the moment. And we plan to do this analysis for all of the Tiger sites. And this understanding will really help the industry move forward and help us understand in these areas where there's a lot of interesting research going on, what's the size of the prize? So yeah, thanks a lot for listening, and I'll take any questions.
This is the bit where I step in.
I'll move to the side.
I encourage the audience to. Okay, thanks for a great presentation. And great, we've got a question up there. I've just got a little joke to get in. So Kieran, I was really impressed that you were able to talk about Ramsey Sound and not mention the bitches. So very good, well done. Hi Jen, have you got a question for Kieran?
Hi Kieran, Jennifer Fox at Aquaterra here. I'm a marine biologist, so very ignorant to all of this, but very interested. I'm just wondering about the standardization of the methodology that you've used here. Is this something quite novel that you've developed? Is it something that needs further standardization in your view, or will it have to be kind of reinvented? Or do you think developers or project developers will have to reinvent this kind of constraints analysis with each new project?
So we do have within Tiger one of our work packages, which is being led by one of our partners, Senio. So they operate the Pampol Brayhat test site with EDF. And one of our deliverables is looking at this exact question. So they're developing some standards and they're going out to industry and understanding what these constraints will be. So that has fed into this analysis quite heavily. But you're right, it is quite device specific. So a lot of this has come from our project partners as well, who have inputted and told us, what water depths are good for them, what seabed sediments are good for them. But in theory, we have the data and it is very easy to replicate. It's a bit fiddly in GIS. I know Aquaterra, you have your RAD map, which is a really great tool, which is maybe more suited for something like that. But yeah, so it's fairly easy to just apply those cutoffs and do the analysis.
Thank you.
I have a question, and that is some of those sites are offshore and really very exposed, and many of the sites that we've looked at so far, Pentland Firth, Ramsey Sound, are protected. What do the developers think about the wave height and what wave height is tolerable?
I mean, it's a great question, and it's something that we are aware of. So we're currently in the process of procuring an extreme wave height data set. So we'll hopefully be able to answer that question. I mean, in terms of this map, I think the North Bishop site is quite interesting because there are a few islands up there, the North Bishop Islands, which I think could provide some shelter, but it is something that we're aware of. We've talked to some of the project partners, so Orbital Marine Power have provided some really great insight into this, and their kind of summary for us was actually, we kind of wouldn't rule out anywhere, you know, if there's a resource there in the future, who knows, we could design a device that maybe would be more suitable to these extreme wave climates. So it's something, yeah, it'd be great to hear from developers in the audience, but it's something we are aware of and we will investigate in the future.
Yeah, I can chip in. Callum from Orbital Marine again. So we can survive surprisingly high wave heights because the peak loading on our device actually occurs when we're producing peak power, where the thrust in each rotor can be in excess of 100 tons per nacelle. So given that we have to design for those very high loads, the loads that occur in even a 20-meter wave are actually a good bit smaller than that. So the maximum wave height that can occur on the site is rarely, and has actually never been a driving factor for any of the sites we've looked at so far. What's more important to us is like the occurrence of small, like moderate size waves that would cause us to have to shut down power generation, and it would affect us from a yield loss point of view rather than a survivability point of view. And yeah, we'd have to assess the sites, but I mean, a lot of the sites, like, you know, anything in the English Channel, I mean, that's pretty exposed anyway. And the Penland Firth itself is still massively exposed. A lot of waves get funneled in there from the Atlantic and the North Sea, and all these sites are definitely valuable from both the survivability and the yield point of view. So I wouldn't be scared or pessimistic looking at these sites when the time comes.
Yeah, that's great. Thank you.
Yeah, just a quick question from me. I guess from my experience, one of the issues has been that in the past, when setting these types of constraints, they're set rather arbitrarily without too much information from specific developers or turbines. And so even with small changes in, for example, the maximum flow speed or whatever you're using, you'll see a very different map. And so I guess a question again for the developers, similar to what's already been asked with waves, but if there is any information that could be provided in order to update these maps for specific devices, then that would be really useful in order to establish which turbines are suitable for which sites and which ones are going to be economically viable. So maybe not a question for straight away, or maybe if you wanted to answer that now, that'd be great. But if you're open to sharing that sort of information, that's something that I think would be really helpful.
Yeah, I'll touch on it quickly from our perspective. So we did send out questionnaires to all of our partners asking for these constraints. So we do have such data. We'd have to obviously ask if we could share that because there is confidential stuff in there. And I think part of the reason why you see, you know, in the table, I've taken different densities. There's that min and max area available as well. So I did consider sensitivities to try and get a feel for, you know, an upper and lower bound. But I appreciate that it is fairly coarse and it does change quite significantly with the assumptions. You know, based on this, you know, in Ramsey Sound, it could be between kind of 4 and 45 megawatts, which is a huge range. So I think there is more work to be done in this area.
Hi, Athanasios Angeloudis, University of Edinburgh. Just an idea based on this, and following up on what Danny suggested on the arbitrarity of the constraints, have you thought about disseminating the suggestions that you created here through the SuperGen and asking the rest of the community what they think about these quantities that you selected? For example, what I was thinking immediately looking at this, you've chosen the peak spring tidal velocity, but many studies suggest that you wouldn't use this peak tidal velocity to define your device. We might use something like 71% based on various previous documents. It might be, if you basically ask the community, you might get a lot of interesting feedback, which might be useful to disseminate just to see what the perceptions we all have about this and get a better understanding of the consensus that exists.
Yeah, no, it's a great question, and yeah, yeah, drop me an email, and I'd love to do that. I mean, through Tiger, most of this work will be made publicly available, so it will be going out to industry, and we will be checking with partners, etc., on their thoughts and refining it. So it's definitely something we can do. I mean, in terms of, I think there is a lot of debate on these kind of issues, and a lot of different devices, etc., will have very different properties. So I think there is a danger of, if we kind of listen to everyone, nothing will ever get published, because someone's bound to disagree with something we've done. But no, I think it's a great suggestion, and yeah, we should have a talk.
I think it's just would be interesting to just expand into the academic world as well, and also just to do this kind of analysis of what the community thinks, and see what the academia thinks and what the industry thinks, because I think this is what we're trying to bridge through these activities at the moment.
Yeah, absolutely, and that's one of the core aims of Tiger, to do this. So no, it's a great comment, and yeah, completely agree.
Thank you.
Thanks very much, Kieran. I just want to check to see if there's anyone actually from Cambrian Offshore Southwest online, and whether they want to come back on any of this, because obviously they're responsible for the Ramsey Sound site. We tried looking through the list, but I couldn't recognize any names. Okay, maybe not. No. Okay, last chance for any questions. I'll draw this to a close. John, anything else online? No? Lovely audience. Any other questions? No? Still awake? Yeah? Yeah, most of you are. Great. Okay. Thank you very much indeed for your time. Thank you very much for coming to this session. I know we were in competition with other sessions, but hopefully you got something out of this. I think we're all passionate about tidal energy in particular. We all can see its relevance, but there's a lot more work to be done. As we've said a couple of times, we will take the questions from this and consolidate them. There is opportunity to get involved in the Tiger project if you're not involved at the moment. And come and see me, or email me about that. Thank you very much to Danny. Oh, you're up there now. Thank you very much, Danny, for pulling all this together, and anyone else who was involved, and John for sitting back and letting it happen. Is that right? That's unfair, isn't it? But isn't it great to get out again into the big world and just sort of see each other and realize that, yeah, we have got legs. It's just not a face on a screen. So good to see you all here. Enjoy the rest of UTech. Enjoy the rest of the evening. Thank you very much. Can you give a round of applause for our speakers, both here and online, and for all the contributions? And thank you for the technical support at the back. Brilliant, great. Thanks very much. The doors are unlocked. You're free to leave.